there's a pretty popular argument that absolute zero exists or not. The existence of absolute zero. So I'm gonna have to prove, because I am biased towards existence of zero. The absolute value of zero, not like 0.00 like dx or something like that. No, absolute zero. So hold on to that. I have this blank sheet of paper and I'm gonna draw something and I'm gonna speak, so you don't have to think that I'm kind of ignoring and stuff. So you ever heard about the mass changing as velocity is written by m equals m naught over under root of 1 minus v squared over c squared, where v is the velocity of the object who has the mass mn for which we are concluding and doing all this stuff, and the c is velocity of light. So that's what the equation looks like. Yes. So let's make a graph. We say that there exists infinite amount of real numbers between 0 to 1. More than the infinite numbers that can be on the total graph, total the x line. So I'm gonna have to prove that right. But we can also do a quite change in that, and then let me explain the graph. So the most popular definition of infinity is given by the graph over y equals 1 by x. So I'm gonna draw the graph, which looks like this. You probably have seen this, and the line, this line, never touches the x-axis, and we say because there are infinite real numbers between 0 and 1. So the concavity of this graph actually occurs when we are between the intervals 0 to 1. So this is not the thing. The actual part is that let's imagine a race between let's draw a good old car. So there's our car. We name it Lambo, right? So that's our Lambo, and we draw a turtle and we name that turtle Lacey. So here's our turtle. Okay, but the race starts from here, and it's actually 100 meters long. So whichever completes the race faster is gonna be the winner. Of course, that's a normal thing to do. To note. But we do a slight change. The distance here to here is 100 meters, but the distance from the car to the turtle, between the center of masses of them, is, let's say, 10 meters. So we kind of actually give the turtle a 10-meter head start, right? So, and then my friend over here, who is called the coach, he just pulls the gun, and then the race begins. So what we do when we try to solve mechanics problems is we after the thing, whatever we're doing, the actual experiment, it is done, in the middle of it we take an instant, where instant as in here, we took an instant, right? So we take an instant where we can apply the rules of calculus and stuff. So we take an instant in our race, so-called race. So what actually happens when there's an instant where the car is actually 1 meter behind the turtle, right? 1 meter behind the turtle, because the car is actually fast and the turtle's like 25 centimeters per second per minute, and the car's like a kilometer. So yeah, this is actually gonna be like this. The turtle moves this slow and the car moves this fast. So yeah, depending on the speed, it's not actually infinite, right? It's a finite speed of like 100 meters, 50 meters a second is a finite speed to a car, and so is the turtles. So there's gonna be an instant where the turtle and a car must have a distance, let's say very small distance. So we can use calculus, right? We say dx, right? And the distance from the starting line and to the turtle is x. So we actually take an element which is x. So if we apply the rule of velocity and stuff, because they're having a constant acceleration from the start to 50 meters, the car is going to accelerate from 50 meters and then it's going to stop, right? And then because there's a limit of acceleration to a car, of course there's a limit. It's not like you can always accelerate your car. You can just press the pedal from there to there, and it's not like well, you know what I mean. So, and the turtle doesn't even have an acceleration. It's so diminishingly small that you don't even notice it. So what we're gonna do is we took the element dx. So the velocity of the turtle with respect to the car is actually the velocity of car minus the velocity of turtle, right? But as we actually see this in perspective, the velocity of car is literally very high to the as compared to the velocity of turtle, like 1,000 times over. So velocity of the car with respect to turtle is kind of negative. Look, when you do it, velocity of car with respect to the turtle is equals velocity of car minus velocity of turtle, which is going to be negative. Of course it's going to be negative, y'all know that. But there's going to be an instant where the distance dx nearly approaches to 0, where the most interesting things actually happen. So as earlier I told you, the mass and the velocity relation is actually similar to the mass equivalence relation, E equals mc squared, but we're not going to talk about that because it's quantum physics and it's only applicable to quantum particles size below the Planck size inside the Planck's range. So it's not the Planck's range, it's way higher than that. So actually, if we see in reality, we're talking about real numbers, right? So we see in reality and we see that the car does actually pass the turtle, right? And according to the infinite real number theory, it's actually when the car is 1 meter behind the turtle, when the car is 0.1 meter behind the turtle, and when the car is 0.000001, and then like when the car is 10 to the negative n, where n tends to infinite, right? This expression right here, let me circle it for you. You cannot see it, it's probably blind shit. N tends to infinite, 10 to the negative n. And when you use limits, calculus, it's way too much of approximation, so we're not running on approximations here, so it's not gonna be 0 here, because if we apply a limit here, then what is it? No? Yes. If we apply a limit here, then it's gonna be 0, of course. But no, we're not running on approximations. So n tends to infinite, like 0.000 tends to infinite, like infinite that you cannot count in your whole life. That's what infinite here is. It's not actually the thing that you cannot. I'm not saying not defined. I'm saying infinite. There's a way more difference in the two terms. So yeah, so it's actually 10 to the negative n, which is gonna be really small, right? You cannot even put the zeros if you make a line from here to a straight line, and then it's gonna extend to Alpha Centauri. Alpha Centauri is a star really far away, some like fractions of a million of light years. So that's really too far from our approaches and reach. So yes, but according to the infinity reality numbers theorem, it's never gonna get across it, right? The car is never gonna pass the turtle, because it's the amount of acceleration that the car is putting in and the speed that the car is putting in and the distance it's covering, it's not decreasing, yeah, it's decreasing the distance between those, but it's not tending it to zero, right? It's just decreasing it. So there arises a paradox. Does the car actually... So that means that the car is never gonna pass the turtle, right? That the car is not gonna win, or maybe the race is not gonna end. So the thing is, the race does actually end. The car does pass the turtle. The car wins. That means there are actually not infinite number of real numbers between 0 to 1 or whatever numbers. Absolute zero exists. Thank you for watching. I'm looking forward to put these things up. If you like, make sure to put down everything in the comment. So yeah. So look at this. This is what I wrote. Alright, thank you guys. I wish you like.